Drag and drop instructions. Creating rungs of logic using drag and drop. This is kind of where we left our project. And in the next project, drag and drop editing, we had you save your project and go to the offline view. So I'm going to close down the pop-ups for those database files and go to the offline. Well, I'll save it. I'm not really paying attention to what name I'm saving it as because my only interest is really recording these lab discussions. The first thing I had you do is to mouse over this instruction and drag it down to here. Now you see all the red memes there, or drop me here, drag and drop me here. I had you, when that one was green, let go. Now I'm doing this because I want you to see if you grab something in the offline view, you're moving it. You're not making a copy of it. It's not like we'll move it back up there. It's not like I went over it like this and did copy, selected the focus there and Control V. It's not like I did, and that didn't even put in there what I want. So evidently I had copied this last. Copy, paste. That's what I wanted to happen. So it's not like I copied and pasted. So if you just grab it here and move it to here, you moved it. You didn't copy it. When you move something, it's no longer where it was. Okay, so I had you put it back the way it was and then go online, because remember, we still have this code online. So comms, system comms. Okay, then I had you try it online. You're dragging it, but you're not. There's no place to drag it to. Notice there's no memes. You can't drop it anywhere because you cannot edit rungs of logic in the run mode. We'll put it in the program mode. And I'll try that again. Nope. As long as you're online, you cannot edit a rung unless you put it in the edit mode. If I double clicked here and put this rung in the edit mode, then see, now I've got memes popping up there, and I could take and put it there. Another thing to notice is when you're online, you're copying and pasting it. You're not moving it. Offline, it literally removes it and puts it someplace else. If you're online and you do this, and you do it from a rung that's not in the edit mode, you see this one's in the edit mode, right? So I'm going to delete that and do that again. If this were in the edit mode, and I did that, down to here, see, you moved it. So I'm going to cancel the edit modes to get it back the way it was. So what I was demonstrating here was, you got to be careful what you're grabbing and dragging. If it is a rung that is running, you can grab a copy and drag it someplace else. If it is a rung online in the edit mode and you grab it, you're moving it. Offline, you can do anything you want. It's kind of nice online because if you see something you want, we'll put this back in the edit mode, and I suddenly decide I want this one of these here. I drag it down there. I haven't touched this rung. It's still the same. I saw it, I grabbed a copy of it and brought it down. As I demonstrated, if this had been in the edit mode, you would have moved it instead of just copy and paste. So I'm going to undo the red X here, put it back the way it was. Another thing I want to demonstrate is I can grab just the address, but see, there's no place to drop it. If I was in the offline mode, and I grabbed a memory location, look at all the memes. I can drop it any place I want. And if I drop it someplace, like here, it doesn't remove it from here. So if you grab an instruction offline or in the edit mode, you're moving it. If you grab an instruction in the online running mode, you're making a copy. Okay, so we'll undo that to put it back the way it was, and we will, well, I was going to undo it, but I just hit verify, same thing. Then I had you double click on the header of rung 0. I'm going to, this is offline, and that's not what I wanted. You were online when I was having you do this. So I'm going to verify that, and I'm going to go back online. I really haven't changed anything, so I'm just going to go online. Say no to saving changes. I'm in the program mode now, and I'm going to show you something. Double click. Now you notice that these are black. R for run and E for edit. I'm going to put this in the run mode. Watch the E and the R. See, now the R is green. These are called edit zones. For safety's sake, you cannot edit a rung that is actually being executed, but you can edit a copy of the rung, test the copy, and then insert the copy in place of the original. So right now, when I double clicked on rung 0, now it shows 0, 1, 2, and then the end statement 3. There's only 2 rungs running, 1 and 2. And that's indicated by the green. See the green R's for run and E for edit. So I had you double click on the header of rung 0. Then I had you drag and drop a memory location, input 0. I had you drag and drop output 0 to this memory location right, or this instruction right here. Got to be green. I dropped it when it was red. It's got to be green when you drop it. Did the memory location move or copy and paste to the instruction? It copied and pasted to. The next thing I had you do was to select this rung with a single click and then hit the delete key, or you could right click and hit delete. Now we have 3 different types of edit zones. We have a D for delete, and R for run, but being edited, and there's the edit rung. Now we're in the online view, and we just caused a different edit zone, D, delete zone. Notice that both the lowercase r and the D are green and running. We marked that rung for deletion only. We haven't actually deleted it yet, because we have to do some other steps before we can do that. Okay, we're going to watch our online toolbar here. Okay, right now with this, the highlight here, I've got these 2 choices. If I move up here, notice now that I have an accept. So I'm going to accept, test, and assemble. When we put this rung in the test mode, notice that these R's are now black and these I's are green. So it's actually running this rung. This is the only rung that's being run right now, is this rung. See, these are black, which means that in the test mode, we're testing all of the edits that we made. Both editing this rung to a change in address, memory location, output 0 instead of B30, and deleting this rung. So in the test mode, we're testing both of the edits. I can untest it with this button, and we go back to running this rung and running this rung, or test it, and then assemble the edits. Now see, we only have 1 rung left. And the last thing I pointed out was, you know, we're working with this online toolbar. So we had test, untest, we have assemble, we have verify or accept if you like that better, or cancel rung edits, or cancel all edits. But here we have a button that if we click on it, it puts it in the whatever's in focus in the edit mode. Now watch this button right here when I click here. See, it's grayed out. So the end statement, the end rung, there's nothing you can do with that. You know, you can't put it in the edit mode. You can't, remember I said you can't touch it. It's just there to indicate that's the end. So if I go here though, if I click here, say put it back into the edit mode, or I can cancel. I can also double click the rung and cancel. Next we added another rung, so we grabbed the new rung instruction, brought it down here, and then while the focus was still on this rung, we clicked on this. You see it dropped in an OTE. Where is the focus? The focus is on the OTE instruction. Okay, now watch carefully. In the lab we had you right click and accept rung edits. And this is what you should have got. And we did mention this earlier. What was overlooked? Well, what was overlooked was we did not finish that instruction. And it tells you right here, operand not entered. If I click on this, I'll just say, okay, I read the message, rung has errors, cannot accept, okay. Then if I click here, it tells you rung 1, instruction 1, error, operand not entered, and it'll highlight the culprit. Then I had you grab this memory location or pointer and drag it down to that OTE, and now we'll accept, test, and assemble. Okay, this demonstrates one of the most important things that you're going to learn about PLC programming, and that's the concept of last man wins. If we have 5 people standing in line and we're asking them in order what the group is going to have for lunch, if the first one says pizza and the last one says Chinese, then we're all having Chinese. Last man wins. So when you look at these two rungs of logic, the first one says if input 0, 0 is on, then this instruction is true, then turn on output 0, 0. However, input 0, 0 is not on, so that instruction is false, so it tells output 0, 0 to be off. However, the very next rung, which is unconditionally true, there's no permissives, no conditions to be met, it just says, hey, output 0, 0, you're on. Last man wins. If we were to flip these two rungs around and put the rung 1 first and rung 0 last, you'd see the exact opposite state, which this is what we're going to do in lab. So let's grab this guy, drag him up here. When it turns green, we drop it. Now we're going to accept, test, and assemble. Now look, the first rung unconditionally says you're on. The second one, it's false, so it says it's off. Last man wins. Whatever is the last rung to address that memory location pointed to by output :0.0 / 0, last man wins. To further emphasize this, flip the switch on. Now it's on, right? Last man wins. And this looks true, right? Think about it. The first rung is unconditionally true and output 0, 0 is on. The second rung is true and output 0, 0 is on. So if you didn't know any better, you wouldn't see any problem with this. However, if we flip it back around the other way, it still looks true. Unless we turn the switch off. Now it doesn't look right, does it? Keep in mind, last man wins. That's one of the most important things you're going to learn in class, especially when you're troubleshooting and you're looking at something and you're thinking, well, how in the world can that be on? That's false, because you never want to have two OTEs addressing the same memory location, because the last man wins. Let's say that you could see this rung 0, but this was actually like rung 117. It was not in sight. You'd be looking at this thing. You'd be looking at rung 0, going, "Oh my goodness, what's going on here? This doesn't make any sense at all." If you see this in the run mode, and you know that you're executing ladder 2, and ladder 2 is the only ladder file, program file, that executes automatically in the run mode, period. If you add ladder 3 through ladder 255, they don't execute automatically. You have to add something to get the program execution to go look at those other routines and run them. But for right now, ladder 2 runs automatically. So if you're in the run mode and ladder 2 is the only file, and that's the one you're looking at, and you see an instruction that's false but an output that's on, you have to know someone somewhere else is turning it on, whether you can see it or not. Okay, we're still in the online run mode. So I had you grab the bottom rung and bring it up to here, as you see here. Accept, test, assemble edits, click on rung 1 to bring to focus. Drag and drop a true if off instruction into the rung, which we can't do running. So we have to double click to put it in the edit mode, then drag it down. Then we can drag down the address and drop it. And then accept, test, assemble, and we're running. Now is where we kind of discussed what we're looking at here. Now I show the switch off right here, and we know that because the bottom instruction is true if off. If I flip the switch on, now this instruction is true, but it shows the bit off because last man wins. This instruction is false, so it turns this bit off. Even though that rung is true, it is setting that bit, but microseconds later, after it's set the bit to 1, it's setting it to 0. And so that's what you're going to see. Last man wins. A couple more questions in the manual on this logic. What does the on-off state of the OTE output energize instruction, why does it not reflect the logic of these 2 rungs? That's because last man wins. Now this one, this looks okay. First rung is false and the output is on. So the true and the false is more important than the on and off. So see here, the rung is true, rung 0 is true, but the output is off because rung 1 is false and turns the output off. The last couple questions there, why does it not reflect the logic of these 2 rungs, last man wins? Can both of these rungs ever be true simultaneously? No, they cannot, because you have a true if on, true if off, pointing to the same memory location. So one of these instructions has to be false. Can both of these rungs ever be false simultaneously? Again, the answer is no. The order has been reversed, but does each prospective rung still read the same logically? Well, you could say yes or no. I'm going to say no, because no matter what you do, there's a state of that switch where the logic's not going to look right. If you answered yes, that's okay, as long as you understand what we're doing here. Is the result the same after the controller scans both rungs of logic? Well, again, that's debatable. If we reverse it here, so we have the switch off, right? If I drag this up here, accept, test, assemble. See, now these are shown off even though this is true. If I flipped it back the other way and drug it down here, now it shows the bits on. Is the result the same after the controller scans both? No. Why? Last man win. Okay, continuing with ladder logic instructions. I had you drag this instruction. It really doesn't matter what order these are in. If you like it better in this order before I make the edits, I can do that. Then I put this in the edit mode and drug this up here. I also changed this instruction to a true if on, deleted that rung, however, I needed to change this memory location and I did not give it a name. That's okay. I know it's a very annoying sound. A few more edits and text changes. Okay, I've changed the symbols to stop push button, start push button, and motor 1. I'm going to put the rung in the edit mode. I'm going to put my focus right here on the start push button, and I'm going to do a branch around. Now I can drag this to any of the mimes. I'm going to drag it to here, put my focus right there, and then click on that true if on, grab this memory location and drag it down. And we have the logic. Now we have one more change to make. This is the classic start-stop circuit of the entire industrial controls universe. And it doesn't matter whether you got the start push button and its branch around second or first. We could move the stop push button over behind it. You know, we could move it from here over to here, and it would still work the same because the instructions are in series. This is the way I have it drawn in the book. This is the way we're going to use it. One more thing that we have to do, and that is this needs to be true when no buttons are being pushed. So what I'm going to do is turn on switch 0, and you see now it's true. Now if you're using my simulator, I have it wired up so you can use it as maintained on, maintained off. If the switch is up and on, then the push button next to it is connected as a normally closed. So if I push that push button, watch the stop push button. See, it goes false. I'm not pushing, now I am pushing. They're enhanced inputs, so you can use maintained on, maintained off, or normally closed, normally open. So this is right now a start-stop circuit for a motor. And if we were to operate this to test it, we hit the start push button, which is input 1. Notice that the rung is now true and it turns on output 0, the motor. If I let go, it stays on because the true if on instruction below the start push button was true before the start push button was false. So we've completed the basic start-stop circuit that behaves just like an electrical start or start-stop circuit. If I push the stop push button, input 0 is the stop push button. If I push that, the rung goes false, and when I release it, it stays off. If I push the start push button, let go, it stays on. Is the behavior of the ladder logic equivalent to that of the electrical circuit when power is cycled? Yes. Basically what that means is if you cycle power to the controller, that if you turned off the power in this state, when you turn the power back on, the logic will have dropped out and the motor will be off. What does this logic remember? Remember, we were calling this logic that remembers. It remembers that the stop push button instruction, true if on I:0, 0, it was true when you push the start push button. That's what it remembers. So it's sealing logic. You are sealing in the temporary condition of the start push button with the bit that it turned on. And because the logic scans from left to right, top to bottom, and I have the start push button pushed right now, true if on input 0, 0, and true if on input 0, 1. Wrong is true. It says, hey, output 0, 0, you're on. The next scan, if it comes through and it says input 0, 0, are you on? Yes, I am. Then this instruction is true. Then it reads the next true if on input 0, 1 and says, are you on? No, I'm not. Well, then you're false. But because there's a branch start and the next branch instruction, it says output 0, 0, are you on? You are, then I'm true, turn on output 0, 0. And as you all know, the logic is dumb as a brick, the controller is dumb as a brick, and every single program scan over 1,000 times a second this rung is being scanned and turning on output 0, 0. Nonetheless, output 0, 0 is already on. The controller doesn't know that and doesn't care. That would be like you telling someone to stand up, and every time you look around the room, Jimmy, stand up, Jimmy, stand up, Jimmy, stand up, even though Jimmy's already standing up. Now, Jimmy might be offended, but believe me, this bit in memory does not know one way or the other. If this rung goes false, in other words, if I press the stop push button, the rung is false, and over 1,000 times a second, this rung with a rung out false tells output 0, 0, you're off, you're off, you're off. Sit down, sit down, sit down. Over 1,000 times a second, the false execution of the OTE tells the bit that it addresses that it's off. OTE is somewhat unique in that it has a true and a false execution. When it's true, it turns the bit on. When it's false, it turns the bit off. If I were to turn this bit on and then delete the rung and then leave, when I came back, that bit would still be on because the last thing it heard was, you're on, you're on, you're on. So if I hit the stop push button, now it says you're off, you're off, you're off. Good enough.